Hello friends, in this session we will going to do the data analysis in Excel for CRD design, okay, having 2 replications and 17 treatments. This is a equal number of replications or observations or plot. You can mention here the character name, whatever character you choose for the analysis, you can mention the character name over here. For example, we can consider, just let me change the color of that character name, just make it red. Okay, I want to put plant weight. Open parenthesis, gram, close the parenthesis. Okay, you can mention whatever character you selected for the analysis. You should have to mention that character over here. Okay, just below that you will get the treatment table. In that you can see here number of treatments we selected for this analysis, 17 treatments. So we just gave the name for each treatment, the T1 to T17. So we need to give the input data here. You can see here the all cells are blank, so that we need input data which is obtained from field, okay, or any research lab or any polyhouse or control environment condition research data. Okay, whatever data you have you can put in the CRD design. This design is mostly recommended for control environment condition experiments, for example lab experiments or polyhouse experiment. Okay, so you can put here data manually. If you have data in your notebook, then you can put manually. If you have data in this same format in Excel, then you need to copy paste. I'll show after this. Okay, so if you have the manual data, you can just put the values 20, 25, then 30, likewise. Okay, whatever your values you can put here. Next, we can do the copy paste of values. For example, I have the example over here. This is data. This is the just random data for the analysis purpose, because we consider just a random data to do how to do the analysis in Excel. Okay, just this is random data. This is not actual field data. Okay, this is a random data. Just copy the data, come to our design, click first cell. This is the first cell which is correspondence to the T1 and R1. You can R1 you can call it observations, or just you can call it plots. Right click and you have to choose here the options. Okay, you can see here the paste options. You can see here the second one. We need to paste only values over here. Okay, just click on it. Okay, all values are here. You can see this is fully automatic design. You will get everything which is needed for your research. Okay, I'll explain everything in this video, so you keep watching. Okay, just you can see here. Okay, let me show you something. Okay, you can see here. You will get the grand total. Okay, grand total means the total of all the treatments with respect to their plots or replications. It means if you click on this, you'll get this formula, sum of all the numbers. Then you'll get the grand total. Then very important, treatment total. You can sum the R1, R2, you'll get the treatment total. And after that you will get the treatment average. You can call it mean. Okay, now you understand, I think so. Then we calculate the replication total, replication average, but this is CRD design, so we don't consider replications, so don't think too much about the replications. Okay. Then below, very important, ANOVA table, that is the analysis of variance table. Let me expand. Okay. You can see here, you'll get the source of variation. Okay. In this design, you consider only the source of variation as a treatments only, not a replication. If there is design like RCBD or RBD, we consider the replication effect as well. But in this source of variation, we consider only treatments. Below that, you will get the error. Another name for error is residual. Okay, or sometimes it's called as error degrees of freedom, for degrees of freedom for error. Okay. After that, you will get the degrees of freedom. In degrees of freedom, I already gave here the formulas for the t minus 1, that is treatment minus 1, then n minus t, and n minus 1 for the total. After this, you will get the sum of square. Sum of square, it's a calculation. To calculate the sum of square, you can consider these are the treatment total, and this treatment total up to 17 treatments, and we need to calculate the treatments sum of square. Means we need to make the square of this value, then square of this value as well, means square of this value, square of this value, square of this value up to this value, and add all the values. Okay, then you will get the sum of squares. Okay, or you can calculate for the error. Then mean sum of square, it's very simple. Mean sum of square means sum of square divided by degrees of freedom. Okay, it means mean sum of square. The NEP calculator, it's also an easy one. It means mean sum of square divided by error sum of square. This is the error sum of square. This is the mean sum of square. Then we calculate in this ANOVA table, if table values. Then very important, we calculate as well significance values. In that you will get to know about the whether our treatments are significant or non-significant. Okay, if your treatments are significant, then here is the sign SIG, that is significance. If it is non-significance, then it is non-significant, NS value. Okay, now in this example, our treatments are non-significant. You know, non-significant, it means there is no difference among all the treatments, means treatment effects are equal. We do this for 5% as well as the 1%. You will get the 1% significance as well over here. Below the table, you will get the very important value, that is CV value. You can see here the CV value, that is the coefficient of variation value. In the coefficient of variation value, keep in mind, if you are research in lab or in your polyhouse, then we should have to consider the CV value less than 5%. This is very high because of our data is very random data, which is not normal distributed data. It's just I put a data for the example. Okay, and for the field experiment, we should have to consider the CV value greater than 5% and less than 20%. You remember all these. Okay, very important values. Then after this, you will get the standard error mean value, then standard error difference value. You can consider any one of them. If you want to put the standard error mean, then definitely you can consider the standard error mean. Otherwise, standard error difference also there. Okay, So another very important value you will get in the next table. You can see here, don't need to go for the t table value because we already put it here over here, t table value for 5% and 1% as well. We will get the cd value at 5% and 1%. If your treatments are non-significant, then not need to calculate any cd value or post hoc analysis. You can just write over here in your thesis NA for 1% or 5%, whatever you chosen in your outline of research work. You can take that unit, okay, whether it's a 5% or it's a 1%. But once your treatments are non-significant, then don't do post hoc analysis. If you want to learn about the post hoc analysis, just let me know in the comment box. So definitely I'll make one video on post hoc analysis, how to do the post hoc analysis for the different designs. Okay, so if you want that information, then definitely ask me in the comment box. I'll make one video on this. Okay, below that you can see you'll get the graphical data representation over here. Just you need to edit the character name, then axis title, and here also you need to give the axis title as the treatments. You can see here the treatment 1 up to treatment 17, and you can also give the character name here if there is a more characters. Then you will get the final thesis table. This is our final thesis table. You can just copy this table and paste wherever you want, or compile the many characters, means whatever parameters you selected for the analysis. Means if you have 15 parameters, then you make a one table. You just copy paste these values and paste there. Okay, now you can see at the end here is my WhatsApp number, and I will also mention my WhatsApp number and link in the description box of this video. You can just message me if you want this type of Excel sheet, because we make custom Excel sheets. Okay, so that if you want this type of Excel sheet for your data analysis, for your MSc, PhD or any research, then definitely contact us. We sell all these type of Excel sheet which is custom. In this significance, some advisor asking probability values, that is probable values. We also provide that if you need. Okay, let me know in the comment box or just contact me on WhatsApp. My WhatsApp number in the description box. Just message me over there if you want to buy this sheet from us. Okay, if any query regarding your research, then definitely ask me. I'll try to give you answer all the questions, whatever doubt in your mind, then definitely I will resolve all the doubts. Thank you so much for watching.